This is one of the best ways that I do to display the full range position of my Cartesian robot arm. By using only one sensor, I could display the actual height within the operation. Moreover, I can control the robot arm in any specific height positions. In industrial control, we could use various sensors, but in my goal, I want to display and track the actual height of the robot arm. We can't use common digital sensors, such as inductive, proximity sensor, photoelectric sensor in my application, because these sensors can't provide me with the full range height number of the robot arm within the operation. That's why I introduce you to the Magneto Sensor. After I implement this sensor to the robot arm, I can visualize the real-time height of the robot arm and command it to stop in any specific height. For example, my Cartesian robot arm is moved up and down. These movements are controlled by a hydraulic cylinder. Suppose the cylinder has a stroke length 2,400 millimeters. Then when we expand, the robot arm is moved down from 2,400 to 0 millimeters and moves up when retracting. In short, the robot arm height is 0 to 2,400 millimeters. So, in order to control the robot arm, it moves up and down. We have to control the hydraulic cylinder. Actually, we can use a timer to disenergize the retract and expand solenoid valve coils to command the robot arm to stop at any specific height. But this technique does not perform well for industrial applications where it requires high precision and consistency. In another case, we can use digital sensors, such as inductive proximity sensors. But this sensor has limitations that it only gives us the presence of the robot arm, not specific height. In contrast, after I use the magnetostrictive sensor, the cylinder movement or the position is fully detected, from 0 millimeters to 2,400 millimeters. If you guys are interested about how this Magneto sensor allows us to track the full range of the robot arm height, I'll make another video about this topic and include how to write a program for this control system too. But in this video, I'm only sharing with you about how we can connect this sensor to the PLC. In order to do wiring installation correctly, first we have to check the wire of the sensor and the PLC. The sensor I used is a TBF-E series. It's a linear displacement position sensor. It's an analog sensor which has a stroke length of 0 to 2,400 millimeters. This sensor has 4 wire terminals. For my sensors, the wire is brown, green, white, and yellow. The brown is power supply wire, plus 24 volts DC, and the ground power is white wire terminal. Whereas the green wire is the signal wire of the sensor transferred to the PLC, 4 to 20 milliampere. And finally, we have yellow wire, which is the signal ground wire terminal. Whereas the PLC that I used is the Mitsubishi PLC, model L6808. The input terminal of this PLC divides into 8 channels. Each channel has 2 terminals, I plus and I minus, which are the terminals that we have to connect to the sensor. Note that the PLC and the sensor are working with 24 volts DC power supply. In order to make this installation work, we would need a power supply which is the 24 volts DC that matches the sensor and the PLC requirement. In the real installation, we would need a rectifier that converts the AC power to 24 volts DC. But in this case, we only focus on the sensor connection to the PLC. I would suppose that we already have a DC power supply for the sensor and PLC. So I just put a DC power supply here, and we directly supply the power to the PLC. For the power supply, the wiring connection is simple when we suppose that we have the DC power supply like this. The blue wire is the plus 24 volts, whereas the red one is the ground wire. Similarly, for the Magneto sensor, we have to give the power supply by simply connecting the brown wire to the plus terminal and the white wire to the ground terminal of the power supply. The remaining wires are the wires which are connecting to the PLC. The signal of the sensor is transferred to the PLC via the green wire. In short, the PLC receives the signal via this terminal, whereas the yellow wire is the ground terminal of the sensor. The wiring installation is finished. However, we still can't observe the real-time height of the robot arm until we build a program. The necessary program that we have to build is about analog to digital conversion. We have to convert the raw signal that PLC received from the sensor to the digital value corresponding to the actual height of the robot arm. If you want to see more about this conversion program, you can let me know. See you soon.